Hello everyone. Let us discuss the Codeforces round 1071 DIV-3 solutions from A to E. Let's get started. So let us begin with the first problem. It is said that you are given a string, okay, of length n, and this string satisfies the following properties, okay. S uses the first k lowercase letter of the English alphabet, and for every pair of I comma j such that j minus I is divisible by x, then the letter si, what happened? Then the letter si and sj are has to be different. Okay, so you can just do this question even just by seeing the test case and don't even have to read the problem also. Suppose first, so let us discuss the first test case. It is given as 2 and 1 means we can use the character a and b, and the given value of j is 1. It is said that we have to arrange and the elements in such a way that if the indexes are divisible by x, then they has to be different. Suppose here the value of k is given as 1, so any repeating character will result in the invalid of the string. So the answer will be 3 because 2 is given, okay. So we can make A and B, and then we have to repeat either A or B. And if we repeat either A or B, then the given condition will become insatisfied, and hence the answer is 3. So let's see the second test case. So the given element has to be divisible by 2. Means if it is divisible by 2, then this I and Sj has to be different. Okay. So suppose basically what do we need to do now? We just the the number of times k is given, sorry, x is given, we have to just make the repeated character that number of times. Okay, so a b b c c, so both of the a distances are less than 2, so it won't be divisible by 2. By adding any single a, the first and that a will become divisible by 2, so it leads to an invalid string. So that's what the question is. Quite a easy, straightforward kind of a question, but the language is quite complicated, you can say, not that of straightforward. So just this is the code k into n plus 1. The maximum array, sorry, the maximum length of string which satisfy the condition is k into n, and adding plus 1 just tells us the maximum length that not satisfy the condition. So yeah, let's go to the second question. It is also a quite straightforward kind of a question. Just we have to do what it is said. In this question, what we need to do that we have to maximize the adjacent sum. Okay, we have in such a way that after removing, basically you are given an array, and after removing any character, okay, suppose we remove the character from the first index, and then the remaining character will be done like this, means adjacent mod sum difference, sorry, adjacent difference mod sum. Okay, after that we have to calculate the maximum sum that we can obtain. Okay, sorry, the minimum sum we can obtain. So just you have to do the brute force approach. Re First of all, calculate the sum without removing any character, and then remove the character one by one. After that, the result which gives the minimum sum will be your answer. How you can do it? See that. Let's see. First of all, we calculated the sum without any problem. Like we calculated the sum, normal sum, and then we just removed the elements one by one. Just see there would be an edge case like if I is equals to 0, then If we access I minus 1 at index, then it would lead to runtime error. So just see that. And if it is not, then remove the previous character from the current character, remove the next character from the current character, and then add the difference of the next character and the previous character. So it will give you the sum after removing that character and take the minimum of all and just print it. So that's what we have to do in this question. Straightforward. These are 800 type of problems. Let's see the third question. It is also, let me read the question. I forgot what was that. You are given an array. Okay, in one operation, you choose an index I and an integer x, which is at least k, and set ai is equals to ai mod x. Your goal is to make all the element of the array identical. Yeah, got it. So it was a better problem than the previous two, but it was also typically 1100 kind of a problem. So yeah, in this question, what is it is asked that we have to set we have to set an index, we have to set an integer x, and we have to set the maximum possible integer x that after taking, let me read 1 second. In one of the operation, you choose an index and at least k, okay, and maximum possible. We have to set an in we have to set k like that after choosing integer x which is greater than k, the result that obtained gets identical if we take the modulo from that x which is at least greater than or equal to x. Let us see the first test case. Okay, if we set the element value to be 5, okay, then every x that would be taken in each case would be greater than or equals to 5. Suppose in first case we took the element 5, in second case we took the element 7, in third case we took the element 9. So in every case, the result that would come out to be 0. Same in the second case, we would set the element to be 2, then 3. So the basically we would set the k as 2, then first then at index 1 we would take x is equals to 2, and at index 2 we would take x is equals to 3, and at both the cases modulo will give us 0. So the k value is 2. So you can easily find out that the minimum value of the element will be the, suppose first of all sort the element. As you can see, we have to sort it, right? And then by the observation you can just see that the minimum value of k will be the first element of the array, and the maximum value that we can get is the second element of the array. Okay, means the range of the answer will lie in the sorted array of first index and its second index. Okay, so see in the third test case. Okay, the answer will lie in between 5 and 11. Okay, why I'm saying that answer can't be greater than 11? Suppose the answer is 11. Okay, which is not possible. Answer is 11 means i- 11 will get converted. Basically, answer is 11. Then we have to select an x which is greater than or equal to 11 and make all the element identical by taking their modulo, which is not possible. Why it is not possible? Because if we take 11, okay, then 11 will result in 0. And if we take the modulo with any other element, basically 11 has to be 0, okay? Because 11, if we take with 12, suppose, then the result will come out to be 11. So for 11, there are only two out, which is 11 and 0. And now see 5. If we take any greater element than 5, then the answer with 5 will always comes out to be 5. Hence, they are contradictory. If we take the element greater than the first index, greater than or even equal to the first index of the sorted array, then it is never possible because the first element and second element itself will contradict the answer. The second element will say the answer has to be either A1 or 0. And the first element will say answer has to be A0. And it is only possible if both the elements are equal. Else it is not possible. Okay. Now see hence we have easily proved that the answer lies between the first index of the sorted element and the second index of the sorted element. Okay. Now, what would be the answer? We have to get the maximum positive integer k. Now, earlier, while contradicting the our answer in that it won't be 11, we have proved that while taking modulo with greater than equal to the index, the answer that will come out to be either 0 or 5. Okay, if we take the if we take the index at the 0 element, like we did in the second and the first test case, the modulo comes out to be 0. And if we take any greater element, the answer came out to be 5. Okay, suppose we took 5, then yeah, all the element will get 0. Like in this case, I will take 5, in this case, I will take 11, in this case, I will take 74. So minimum answer is 5. Okay, now let us see for the maximum answer. If we take any greater element than 5, then the modulo with 5 comes out to be 5. So our aim is to make all the element means we have to find such a k that while taking modulo, sorry, we have to find such a x that while taking modulo with x, answer comes out to be 5. Okay, so for 11, with whom we should take modulo that our answer comes out to be 5. So for that, our aim is to select the maximum value of x. Okay, because we want the maximum value of k. So we would just subtract the given A0 element from every of the index. Okay, and then we would try to find out our answer. Suppose in this test, sorry, by mistake I clicked that. Open. Okay, so by subtracting 5 from 11, the maximum value we would get is 6, 18, sorry, 69, 17, 47, 92, and 77. So by observation, we could see that the answer will be 6 because if we take 6, we are comfortable to take 59 also, 17 also, 47, 92, and 77 also. Okay, so the answer here is 6. So let us see my logic first of all. My logic was quite straightforward. Like, first of all, I sorted the element and I assume that the maximum answer to be 1, A1, which could never be the answer, I know, but still I assumed it. Later you can see that I have done this. Means, yeah, you can. Basically, we have to select any maximum value to the answer. Now, means I know this could never be the possible answer, but still I did that. And then what I did, I subtracted the zeroth index element from every answer and calculated the minimum value which is possible. Suppose in the earlier test case we have seen after 5 the second element is 11. So we got the minimum value to be 6. Okay. But instead of that, we can also do that. Suppose the second element is itself is 6. So after subtracting 5, okay, you would get result as 1. And we already know that the maximum value could be A0. Okay, so the maximum answer is A0. 1 could also be the answer. Okay, but A0 is the, but we have to print the maximum answer. So that's why I written this and we printed the answer. You could also write, means there is also no need of this loop. You can also submit your code without using this loop also. Let me show you how. It just got clicked me right now that you can solve this question without even using this. Wait a second, let me show you how you can do that. Yeah, that's the question. Yeah, CP. Just here do that. Mm, See out max of A0, comma A1 minus A0. That's it. And that's the answer. One liner. You can see it would work. Bust. Because every element, as we have sorted the array, na, so the next element would itself be the greater than the previous element. So it just satisfies our condition. Running on test case one, accepted. Yeah, quite straightforward, like, right? So this is how you can do the question number third. Question number four was a decision question. I guess it is also it was also better than question number five. Okay. So in this question, what it is said that you have to print the lexicographically minimum summation of this. Okay. First of all, let us understand the question. You are given some test cases and then n. Here n represent 2 to the power n minus 1 means array up to the element 2 to the power n minus 1. Okay, means starting from 0, suppose n is equals to 3, so you will go from 0 to 7. That is the permutation of the array, means you have given this array, and you have to take the AND of all elements and print the maximum possible answer that is possible. So yeah, how to do that question? These are quite basic test cases that are given here. Let us take a bigger test case. Suppose we took the test case n is equals to 4. Okay. So for n is equals to 4, we would get a permutation from 0 to 15. Suppose let us take a bigger number. By that I have realized that this would be the answer. Suppose we took n is equals to 5. So for that answer will range from 0 to 31. Okay. While solving this problem, I took this example of n is equals to 5 because n is equals to 4 and n is equals to 3 is quite small and you won't realize that this is how the pattern is going. So yeah, so for n is equals to 5, it will range from 0 to 31. So we have to maximize the AND. Okay, so how can we maximize the AND? For from 0 to 31, first of all, let us try to maximize the element present at the zeroth index. Okay, Let us maximize P0 first of all. How can we maximize P0? P0 could be maximized only by the maximum bit of element present at the P0, and from 0 to the power n minus 1, you can just by observation find that you already know that already, that the maximum element that has the maximum number of 1 bit is 2 to the power n minus 1, which is 31. Okay, so yeah, 31. After that, see this part, lexicographically minimal. Okay, after that, we will find an element of 4 bit because 2 to the power 31 has 5 bit, and then we would try to maximize P1. How could we maximize P1? We could maximize P1 by finding an element of 4 bit because there is only single element of the 5 bit, and the max, and after removing this 5 bit element for n is equals to 4 case I am talking about, after removing the element with a 5 bit, the maximum element present which is present is only of 4 bit. Okay, so and we have to print a lexicographically minimal value. So how can we find an element of 4 bit? Easily, we just right shift, just left करेंगे ना, क्या 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 इसमें करेंगे, just left shift this, sorry, just right shift the number by 2. So the minimum number of, so the smallest number that has 4 bit is 15. Okay, after 31 you have to print 15. Let us see the corrected code of this, and then by seeing the test script, I would tell you guys. Yeah, CP, and then put here 4. Sorry, 5. Sorry, 5. I was till 32. Okay. Yeah. So the lexicographically smallest element that contains 4 bit is 15. If uh, if it is if it has not mentioned that we have to print the lexicographically minimal elements, then we could print any elements of 4 bit. But it has mentioned that we have to print the lexicographically minimal. So that's why we went to 15. And then the obvious question comes out to be, why are you printing 7 here? We can print 23 also. It has 4 bit. We can print the rest of the element like 27 also. It has also 4 bit because we are doing AND operator. Okay. Suppose 15 has 4 bit, which has one which is 111 1111. Yeah. And then if we take the AND of it with any element, suppose we took AND with three any 4 bit element which is greater than 15, obviously the output that comes out to be the number having 3 bit. So why we print any element with greater magnitude? If we have to print lexicographically minimal, right? So we will print any element with 3 bit which has minimum magnitude, and that is 7. After that, you could ask that, then why are you not printing 3? Because obviously, if we will take and with 3 and with 3, the output will comes out to be 2. Means, sorry, if we take and with 7 of any other element, the output will comes out to be 2, but that's wrong. We can easily find an element with and the output will still comes out to be 3, not 2. Why not with 15 and 31? That's the question. With 15, it is not. How a number? How and works. First of all, let us understand this. With 7, we would find an element with and 7 means with ha which has 3 bit and which is greater than 7 we will obviously find because any number less than 7 has lesser bit than 7. Okay, so how can we find that number? Uh, we can find that number, insert 1 bit after 7. So 7 is 111 and then the insert 1 bit at the left of the 7, so 1111. That would be 15. But as you can see, we have already printed the value 15, so we can't go there. Then what you do, insert 0 and then 1, 1, 1, 1. Then the output, what will be the output will be 23. Yeah, that's what we have to do. Okay, we have to find a number that has 3 bit as of 7 at the end and which also returns 3 while ending with 7. So that number comes out to be 23. Why didn't we do with 15 and 31? Suppose we try to do it with 15. With 15, 4 ones, if we insert 1 at the leftmost bit of 15, then it would result in 31, which is already printed. And if we insert 0 and 1, it would result a higher element than 31. But our maximum limit is only 31. So that's why we did not did this thing with 15 and 31. But we did the same thing with 7. So the number that comes out is 23. How, what is the logic? How would we find that number? Find the maximum bit of 7. The maximum bit of 7 is 4. Maximum value of 2 to the power contributing into 7. That's what I am saying. So while making 7, the maximum power of 2 that is contributing in the formation of 7 is 4. Okay, so just multiply 4 with 2, 8. 7 plus 8 is 15. Then 15 is already present. We can't take that number. Then again multiply that number with 2. 4 into 2, 8 into 2, 16. Then add 16 to 7 and add 16, 16, 16 till you get the number greater than 31. So 23 is being printed. If the number would have been 63, then we would have print 39 also, 55 also. Means we would print all the numbers with the addition of 16 like 7, 23, 39, 65 and so on. 39 and 55 and so on. Okay. Same we did with 3. After 23, by ending with any number, we would get only 2 bit. So we had printed the lexicographically minimal, which is 3, and the maximum value of 2, which is contributing in the formation of 3, is 2 only. So if you multiply with 2, 4. If we add 7, that is already present. So we will again multiply with 2, 8, 7. So 3 plus 8 is 11, which is printed. Plus 8, 19, which is printed. Plus 8, 27, which is printed. Like that, we would print for the 1 also. And then after that, if we will add with any element, the number of 1 bit count is 0. So we just printed all the even number in lexicographical manner. So this is the whole explanation of the question number 4. It was a good question, I guess. 1400 kind, you can say. Yeah, less than that, I don't know, but for me, it was a good question. Yeah, this was the code. Just I have wrote it down what I have explained right now. Question number 5, I guess was a bit easy, but due to time constraint, I couldn't able to do that in a contest. I was just lacking in a test case, just in a an edge case, and that's just took all my time. But but I guess it was an easier problem than the previous one. What it is said in this problem that, first of all, let's directly jump into the problem. You have to construct an array and determine whether the construction of these two array are possible or not. Okay, you are given a size n. Okay, and then you have to add all the element of a and make its summation equals to x, and you have to add all the elements of b and make its summation equals to y. And then this is the constraint for every value of n, ai plus bi should be greater than equals to pi. Pi is the array which is given to you. This, this, this. So the summation of both the elements should be greater than equals to pi. And here is one more constraint. If si is equals to 0, then ai should be greater than bi. And if si is equals to 1, then bi should be greater than ai. So yeah, this was the whole problem. And we have to tell whether the construction of the array is possible or not. You just need to see the test case and write your code based on that. That's what I have done, and it got accepted. Okay, what we do in this question? Suppose all the value of string is 0. Okay, this clearly emphasizes that ai would be greater than bi. If ai would be greater than bi, then x would be greater than y. First of all, let us open my code first of all. Okay, yeah, and parallelly open the question part also. So yeah, what I said right now, that if all the value of si is equals to 0, then ai would definitely be greater than ai. And if ai is greater than bi, then definitely x would be greater than y. And if x is greater than y, and then x would be greater than y, and similarly vice versa. So first condition is this. Then there is also a constraint that how much x should be greater than y. See here, it is clearly mentioned that ai has to be greater than bi, and bi has to be greater than ai. Here, equal to sign is not present. That makes the question a bit interesting. Okay, suppose an even number 2 is present, then how the distribution of 2 will be possible? Suppose an even number 2 with string value of 0 is present, then how the distribution of 2 will happen? Let us see that. Then AI has to take both 2 and BI has to be empty. Okay, why? Because if the distribution only 1 1, then this condition won't get satisfied because AI becomes equals to BI, but AI has to be greater than BI. So if the number is even, then the minimum, first of all, we would calculate the minimum value possible for A and minimum value possible for B. Suppose the string value is 0. Okay, so and if pi is even, suppose pi is 4, then the minimum has to take pi by 2 plus 1. Straightforward. Suppose 4 is there. Suppose 4 is there. Okay, then the minimum value of ai has to be 3. Then this condition would get satisfied. Okay, if the pi value becomes 2, then the bi also has to be 2 to satisfy this condition. So this condition won't get satisfied. That's why I wrote it down here. And suppose it is odd, suppose 3, then it would get satisfied by pi by 2 plus 1 only. 3 है तो भाई आपको 2 हमको 1, तो satisfy हो जा रहा है, PI means AI greater than BI gets satisfied by doing this. So yeah, after that we calculated the minimum value using this, and suppose the summation of x gets gets less than minimum a. In that case, we would just print no. And now this is the case. Suppose C0 is equals to n and C1 is equals to n. Okay, here I just calculated the summation of Pi, and you can also see some think logically by AI plus Pi has is greater than equals to Pi, then x plus y will also be greater than equals to Pi because x plus y is a summation of Pi. Suppose add sigma here. So sigma Pi has to be sorry x plus y has to be greater than or equals to summation Pi. If this condition is not satisfied, just print no or okay. And I just discussed the minimum possible value of A and B, and then if this condition is not satisfied, print just no. And suppose all the value of string is gets equals to n. Okay, means all the value of string gets equal to 0. That's why CNT0 is equals to 0. CNT0. Suppose all the value of the string get equals to 0, then if SI is equals to 0, then at every time AI has to be greater than BI at least by 1. How AI can be greater than BI? It would be greater than at least 1. It has to be greater than at least 1 for every cases. So there are n cases. So X should be greater than Y by n, at least by n. And then this condition would be satisfied. So that's what I have written here. अगर उसका difference n से कम होता है, then we could print no. And same vice versa, if CNT1 is equals to n, and then y minus x is less than n, suppose 1 and every n. So bi would be greater than summation of bi would be greater than summation of bi at least by n. So that's what I have written here. And it's so if the condition escapes from these all edge cases, then at last we would just print yes. That's what is asked in this question. That's what I have did. So in the in contest, I was just missing this part. Okay, I was just writing here. Let me. This was very pathetic code. This was the last closest code which I have submitted. Here, I was just missing this part. This part. Here, I written just y is greater than equals to x. Uh, which is wrong. Plus n would be added here. Sorry, here. If y plus n is also greater than equals to x, then also it should print no. So this was the part which I was missing. That's why I could not able to solve the question E during the contest. So this was all about the solution from my side. Thank you very much.